Yeah, so there was some problem with the phone orientation, my bad. So what we have understood from this 1966 IMO problem is a bunch of information from which we have to reduce the answer to the problem. The final question being how many were the number of people who solved only the problem B, right? So let us come back to what we have seen till now. There were 25 people who have solved at least one problem out of all the participants. Of all those people who did not solve the problem A, so those who only solved B or C or B and C both, the number who solved B was twice the number of the people who solved C. And of those people, the number of people who solved the second piece of information, number of people who solved only A is one more than the people who solved A and one more problem at least. And the third piece of information, that of all the people who solved only one problem, 50% did not solve A. Now, let us look at this question and then make an approach in a Venn diagram, right? Okay, so let's look at the third piece of information first. Of all the people who solved only one problem, 50% did not solve A. Now, obviously from a logical experience mindset, you know that that means 50% solved it. If 50% did not solve A, and these are people who solved only one problem, so either A, B or C, 50% did not solve A, 50% solved only B or C. So 50% of those people solved A, right? So let us make a Venn diagram. So this is A, this is B, and this is C. So this is a Venn diagram of what we have to consider and who solved how many problems, right? Now, we have the case that of all the people who did not solve A, the number who solved B were twice the number of people who solved C. So let us say this common region we have over here, this common region between B and C, right? Let's say this has P, right? This has P. Then we know that this should be equal to, let's say, because we know that number of people who solved B is twice the number of people who solved C. So if this is X, let's say this whole area of C, then this area will be 2X. Accordingly, that should be our case to understand, right? So that means barring this area, this curvature, barring this common area between B and C, so this area will be 2X minus P and this area will be X minus P. So one is 2X minus P, one is X minus P. Okay? Now that is one piece of information. Second piece, of those who solved only A is 1 plus who solved at least one more. Now, if you look at this question properly, the region with 1 plus A plus one more, either he did A and B or A and C or A, B and C, all of them, right? So this region, let's say I'm attributing the name Q. This whole shaded region I have here, the common region, is Q. Then this place will be Q plus 1. Q plus 1. Okay? Now we have understood what should be our approach to the question, and now let us make a few equations for us to understand, right? So, we know that this total number is equal to 25. Now let us add 2x minus p plus p will be 2x. 2x plus x minus p is going to be 3x minus p plus q plus 1, aka we are adding 2q plus 1. So 3x minus p plus 2q plus 1 equals 25. And we can further obviously simplify this to the fact that 3x plus 2q minus p equal to 24. We're bringing the 1 to the other side. So 3x plus 2q minus p equals 24. Okay. Now, of all who solved only one problem, 50% did not solve A. 50% did not solve A. So q plus 1 is the number of people who solved only A. So q plus 1 equals half the number of people who solved only one problem. Because we know that of all people, 50 did not solve A. So 50% solved A and q plus 1 will be half of the people who solved only one problem. Therefore, q plus 1 equals half into, now only one will be these three regions, q plus 1, 2x minus p and x minus p. Upon adding over here, you will be getting 2x plus, 3x, because you have one more x to take care of. So it's 2x minus p, x minus p and qx plus 1. 3x minus 2p plus q plus 1. Right. So 3x minus 2p plus q plus 1. Now this is equal to q plus 1 as we have figured out. Now the fact that we know all the information already and we can reiterate and come back to them, let us bring this into a larger dimension of consideration where I'll be rewriting the general equation we have to consider. So till now we have come to the fact that q plus 1 is half into 3x minus 2t plus q plus 1. If we bring the 2 to the other side, we'll see that 2q plus 2 equals 3x minus 2p plus q plus 1. That is what we have to look at right now, right? Now, if we come to, let's say, resolving this equation, we'll get the 1 over here and the q over here. So q plus 1 will be 3x minus 2p. Now, in this equation, 3x plus 2q minus p equals 24. 3x plus 2q minus p equals 24 is one equation, and the second equation we have is q plus 1 equals 3x minus 2p. Now, let us, because the only common element we can essentially see over here is 3x. So let us make an attempt to replace x with what is in that equation. So q plus 1. Now 3x will be replaced with 24 plus p minus 2q minus 2p. Right? So over here we'll get q plus 1 equals, if you can see, we will be getting just a minute, 24 plus p minus 2q. So p minus 2p will be minus p. 24 minus p minus 2q will be what we're getting over here, right? And 2q, if it comes over here, we'll be getting 3q plus p equals 23, right? So that's what we can come to here, right? That's what we can come from looking at the problem which we have taken. Now here we get to see is, we want to know the people who have only solved problem B, right? And the people who have solved only problem B will come in the, if you look over here, it is in the 2x minus p category. So maybe instead of finding a relation between q and p, which is what we have come to here, we can use this initial equation which we have had and subsequently make a relation between x and p, because we want the value of 2x minus p at the end of whatever we're doing, right? So if we look at this equation again, 3x plus 2q minus p equals 24, right? If we look at it again, then we can see that 2q, right? 2q over here equals, if you get over here for example, then we'll have, we don't want q, okay. In this question, we don't want to consider ourselves with q at all. And we can see over here that there's a plus 1. So at the end of this, the initial equation we have, we'll be getting q plus 1 equals 3x minus 2p. Okay, this is one equation which I've gotten. Q plus 1 equals 3x minus 2p. And we have to somehow get rid of q in this question, right? So q is, so over here you'll get 2q. 2q equals 24 plus p minus 3x. 24 plus p minus 3x. Therefore, Q will be equal to 12 plus P by 2 minus 3x by 2. And logically 12 plus 1, so we can now write it down as 13 plus P by 2 minus 3x by 2 equals 3x minus 2P. And now what we are left to do is just multiply the whole equation by 2. So 26 plus P minus 3x equals 3x minus 2P. Therefore, 26 equals 6x minus 2P plus P will be getting us minus 5P. So if we look at the equation properly, then it's minus P by 2. And after this, we'll be getting the relation that 9x minus, okay. So if we actually look at this, then we'll also double these sides. So 6x minus 4p and 6x plus 3x will be 9x, and 2p plus 3x, 4p plus p, sorry 4p plus p, yeah, is going to be 5p. So what we'll be getting at the end of this will be 9x minus 5p equals to 26. This is our relation at the end of the day, where 9x minus 5p equals 26. But we want the value of 2x minus p. Now the only possible way we can look at this is either by logic or by hit and try, because at the end of the day, there are only a fixed number of solutions this can have, because we are also limiting ourselves to only a number of 25 participants who have solved at least one problem. So 9x minus 5p. Let us take values, right? What we get to observe after a certain number of hit and trial errors is the fact that, let's take p equals 2. P equals 2 is 10, and 10 is, this is on the minus side. So when this will go this side, you get the 36, and 36 equals 9x. You get x equals 4. So the best value, and this is the only value which fits in, is x equals 4 and p equals 2. Therefore, 2x minus p will be, at the end of the day, only 6 people who have solved only this second problem, or the problem or question number B. Right. Now let's move on to the second question we have to consider today. And the second and third question actually go somewhat hand in hand, because they are relating to the same concept of the handshake problem. But before I can go to the handshake problem, the questions we have, let us understand the handshake question. The handshake question is a cliched question which is used in multiple examinations of international and national Olympiads in different formats. In the normal conventional handshake question, you have n people in a room and you want to figure out how many handshakes it is going to take for everyone in the room to have shaken their hands with everyone else. Right? Now, let's say you are one of these people in the room. Out of the gathering of n people, you have to complete your handshakes with n minus 1 people. Right? So for one person, the starting person, there are n minus 1 people to handshake. Why n minus 1? Because you are that one person and you have to shake your hand with the rest of the n minus 1 people in the room. Similarly, the second person has already shaken hands with you. So now he'll have to shake hands with n minus 2 people. Then n minus 3 has already shaken hands with them. So it will be n minus 3, and this will all go up to n minus 1 plus n minus 2 plus n minus 3 up to 1. Right. Now, how many total handshakes will it take? If you can see over here, we will have 1, 2, so we have how many n's repeating? This is going to repeat n number of times because there are n number of people getting the handshake here. Last person will be 0. Why will be 0? Because that person has already shaken his hands with everybody else. It will be an n minus n, which will be 0. Okay. So what we get to see over here is that n will repeat itself n number of times, therefore giving a value of n square. Right? Now we have minus. Let's open the bracket. We have 1, 2, 3, 4, 5 all up to n. And we know that when we have to add a series of n natural numbers, consecutive natural numbers, 1, 2, 3, 4, 5 up to n, we will get our answer to be as n into n plus 1 whole by 2. Now for understanding, let's put the whole divisor as 2. We will get 2n square minus, and n into n plus 1 can be replaced by n square plus n. Therefore, we will be getting n square minus n by 2 or n into n minus 1 by 2. So obviously, the general or conventional format, there are n into n minus 1 whole by 2 number of handshakes required for n people in a room to shake their hands all with each other so that everyone has shaken their hand with everyone else. But our question has a different approach. So in our question, we have a room of people with n people where n is more than 3. So we have a room of people where n is more than 3. There are more than 3 people in the room. Okay, makes sense. And at least one person has not shaken his hand with everyone else in the room. Now, what is the maximum number of people in the room who have shaken their hands with everyone else? So the actual thing about this question is, it's somewhat flawed. But we have to look at the benefit of doubt of the question, right? Now, the question says the maximum number of people that could have shaken their hands with everyone else. And there's at least one person who has not shaken his hand with everyone else. If there's at least one person who has not shaken his hand with everyone else, then no one has actually shaken their hand with everyone, is what you'll think, right? What is the maximum number of people who have shaken their hand with everyone else? If this certain person has not shaken his hand with everyone else, then everyone is not done with their handshakes as well. What we get to see is that it's not possible for only one person to not be done with his handshakes, because let's say if he is done with everyone barring one person, so there are n people in a room, he has not completed handshakes with just one person, so he has an n minus 2 handshakes instead of n minus 1 handshakes, and even that one person, so let's say there is one person A, and that person B has also not shaken his hands with everyone else because he is yet to shake his hand with A. But it may be a possibility that everyone else has already shaken hands with everyone else in the room, including A and B. Because A is only left to shake his hand with B and B is only left to shake his hand with A. And that is what we'll be looking at when we need the maximum number of people who have shaken their hand with everyone else. We will look at this scenario only. Let's take a person A. Now, we will assume for a maximum scenario that A has shaken his hand with everyone else barring one person B. And similarly, another person B would have shaken his hand with everyone barring one person A. Therefore, barring these two people, everyone out of the n have shaken their hands with each other. They have also shaken their hands with A and B, just like I said so. Therefore, the maximum number of people in a gathering of n people in a room who have shaken their hands with everyone else, considering that there's at least one person who has not shaken his hand with everyone else, will be n minus 2. More than this question's solution, what we can look at is, if we have a gathering of n people, it has to be at least 2 people, if like not everyone has shaken their hand with everyone else. The minimum can be 2, it cannot be 1. It cannot be 1, so there'll be a minimum of 2 people who have not shaken their hands, and the maximum people who have already shaken their hands with everyone else in this scenario would be n minus 2. Now this is a fairly complementary and logical problem we have had. The next one is also a little logical and rather a variation of the handshake problem, but in a different format. Now it's about information, where we have n number of people in a room, or not in a room, n number of people scattered around a certain area or locality somewhere in the world. Each of these n people know one distinct piece of information. So there are n pieces of information which n people know about, each person knowing one piece of information, and all these pieces of information being distinct. Now, what happens if everyone wants to know everything, right? for one person to share his information with the other person, what we get to know is that if, let's say, a person A, this is a part of the question, if a person A calls a person B, then A will tell B everything he knows, but B will stay mum, B will stay shut and not say a word about his piece of information. So what the question asks us in this is how many calls are required for everyone to know everything and all the n pieces of information. Now, why is this different from the handshake problem? The parallel you could have drawn to the handshake problem for it to have the same solution would have been the same thing, where there are n people with n pieces of information, and when A calls B, A tells B his information and B tells A his information. Then also you would have to use the same logic which you use in the handshake problem by adding n minus 1 to n minus 2 to n minus 3, so on. You would have gotten n into n minus 2. But our question does not say that A is telling B and B is telling A. A is telling B, but B is staying shut. That means B will have to make a separate call to A to tell A about his information, and then they'll be educated about each other's information. Now, in a handshake, for example, if A is shaking his hands with B, then the job of doing a handshake is done in the first case only when A shakes his hand with B. B shaking his hand with A is the same event, and we would not like that repetition. But here A telling B or A calling B and telling his information is different from B calling A and telling his information. That means for every one event, we'll have to consider one extra event, right? Because if we use the handshake logic, we have not considered that event. So instead of being n into n minus 1 by 2, it is going to be n into n minus 1 by 2 whole multiplied by 2, because now you'll consider one more event with each event. That means you'll have to multiply the whole thing by 2, and there will be n square minus n, or n into n minus 1 calls required for the information to be passed around to everyone and everyone to know about everything. Understanding how this methodology works is very important when it comes to competitive examinations, because the handshake question and the information question are the ones which are somewhat rotated in the methodologies, but the modus operandi as to what we are going to do in all the questions is going to be the exact same. Now we'll come to our fourth question and penultimate question for today. The penultimate question for us is involving seating of people in a circle, which we have, by the way, dealt with if you look at the previous lesson. But this is a little different, okay? So what we have as information is that there are 2n guests who have to be seated on a circular table. Very easy. We have dealt with how we can deal with circular table, what are the number of circular arrangements, how do we have to consider things, and what we have to do when it comes to a circular table problem. Now let's look at the caveats of this question. In this question, these people have come to someone's home for the party, and that home's master and mistress have two fixed seats for themselves, and they are sitting diametrically opposite each other in this question. Okay? The master and mistress. Now, third piece of information we have is there are two specific guests who are not supposed to sit next to each other. In any format, they will not be sitting next to each other. So, two specific people who will not sit next to each other. And we have to find out how many people are to be seated completely, and in how many ways do you have to seat these people. Sorry, you have to find out the number of ways in which you have to seat these number of people. Okay. Now let's make some sort of diagram. So what you have to consider is, very importantly, there are 2n guests plus the master and mistress. So for example, this is a circular table. let's say this is a master M1 and mistress M2. Then there are two n seats. So this is A1 and A2, let's say. Then this will be AN minus 1 and AN. This will be AN plus 1. And this is going to be A2n minus 1 and A2n. Now the first information I'll come with as to explain how do we approach this problem will be a shocker. Because if you'll understand what you have read in the previous video, then you'll see how shocking it is. But then there's obviously a logical explanation to it. It's mathematics, there's a logical explanation for everything. In this case, what we'll want to find is, instead of looking at how many places, how many ways they will not sit each other, we'll find the total number of ways and then subtract the simple way. If we are not able to find one, we find the total and then we find the opposite of it. So we'll find the total minus the number of events where those two people are sitting next to each other. Total minus next to each other. Okay. Now let's find the total. The total number of ways in which 2n people will sit in a circular table will be 2n whole factorial. The shocker. Right? Because it was in the previous video that we have dealt with, where if there are 2n people, then there will be, of there n people, then there will be n minus 1 whole factorial circular arrangements for them to be accommodated. Why will there be circular arrangements? Because, for example, if you take, let's say, A, B, C, D, then, and if you shift them, B, C, D, A, C, B, C, D, A, B, whatever, they are the same arrangement, A, B, C, D. But if you do that on a line, then it's going to be A, B, C, D, and then D coming to the first spot will be a different event. So it will become D, A, B, C, and then C, A, C, D, A, B. So those will be different events. So for n circular linear arrangement, you'll have only one circular arrangement. That's why we'll do n factorial by n, giving us n minus 1 whole factorial arrangements. Then what is the difficulty in using that formula in this question? Why have we taken a departure? Why is it 2n whole factorial? Why is it not 2n minus 1 whole factorial? It is not 2n minus 1 whole factorial because of these two barriers of the master and mistress sitting next to each other. Meaning that let us look at the problem, this scenario, right? We have an plus 1 and an plus 2, right? In this case, a2n and a1 are sitting opposite or to this adjacent to m, the master one, right? And over here, so there's a seat difference between them because their seat is fixed, mind you. They will not shift if I change the order. If that was the case, then it would be the same, 2n minus 1 whole factorial. The fact that they have two fixed seats for themselves, they'll not budge from that seat because they have organized the party or whatever the question condition we have gotten. If these are the two fixed seats in which the master and mistress are sitting, then if you shift it by 1, a1 will come here and a2n will come here, which means those people who were not close to it, they were not adjacent to each other, they were separated by the master, have now come adjacent to each other, and that is a completely new event altogether because we are considering an event where next to each other and not next to each other is a very important thing. So there will be 2n factorial ways. Similarly, in the case if you go down, here an and an plus 1 are separated. If an plus 1 moves to the seat of an plus 2, then that will be the reciprocation where an will come next to an plus n. So on every seat, it will be 2n into 2n minus 1, blah blah blah, and we'll have 2n whole factorial as the total number of arrangements. Now we come to the mechanic work. We have to find the probability where people are sitting next to each other. Okay? Now let us find how many events you can make where they are sitting next to each other. Rather than events per se, how many pairs of seats you can make? Logically, how many pairs can you make? You can make A1, A2, A2, A3, all up to the end A21, A1. So basically there are A2 and A1. So there will be 2n pairs. Again, the master and mistress point will have its catch to the question. Because two pairs will not be adjacent to each other. For the probability of not sitting to each other, we need to find the probability that they will sit next to each other. But an and an plus 1 and a2 and a1 will not sit next to each other. Therefore, instead of 2n pairs, we will have 2n minus 2 pairs seats to choose from. And you have different units. A1, A2 or A2, A3 is one unit completely, right? So you will require only 2n minus 2 pairs of seats for people to sit adjacent or next to each other. Okay. Now you know how many ways you can select the number of pairs of seats in which they have to sit. And obviously, if we take the A1, A2, then one can switch A2, A1. The person A sitting on A1 and B sitting on A2, they can switch. So 2n minus 2 into 2 factorial is one part. Into 2 factorial. 2n minus 2 represents the number of pairs of seats you can take. Into 2 factorial is how many ways you can interchange. And now we come to the leftover part, where there are 2n guests. There are 2n there are 2n chairs, but now 2 have been occupied by these two specific guests, right? So now you have 2n minus 2 guests to accommodate in 2n minus 2 chairs, right? So that will be 2n minus 2 whole factorial. 2n minus 2 whole factorial. Therefore, our answer will be 2n whole factorial minus 2n minus 2 into 2 factorial into 2n minus 2 whole factorial. After that is a lot of mathematical and quadratic equational work, which I will be, let's say, according to you as homework. Okay, so please deal with that for today. But this is the format which we will get, as 2n minus 2 is the number of pairs we can take, a1, a2, a2, a3, an minus 1, an, or an plus 1, an plus 2, multiply by 2 factorial for interchanging into 2n minus 2 whole factorial. Why have we done that? To accommodate the rest of the 2n minus 2 people in 2n minus 2 chairs. Fair enough. We'll be coming to the last question of probability for today. Now, this is rather a problem of family fighting to some extent. Obviously, there's no fighting part to be actually taken. It's just a mathematical way of representing some part of combination and permutations, right? So what do we have in this question is a person, John. John has X children from his first wife. X children from first wife. From his first wife. Mary is another woman who has X plus 1 children from her first husband. John and Mary marry each other. So they marry each other and they have Y children of their own. Okay? They have Y children of their own. Now, what we have been given as an information is that when we have this family, the children of the same parent cannot have a fight. Meaning John's one X child and another X child cannot fight. Mary's X plus 1 or the other one cannot fight. The Y children also cannot fight with each other. But the Y can fight with the X plus 1. The X plus 1 can fight with the X. That is possible. That is one piece of information. Second piece, the total number of children is 24. We have to find the maximum number of fights which can occur between the children. Right? Now, let us make it simpler for us. We have X plus 1 plus Y equals 24. So one equation we can directly get in the starting of the question only, that 2x plus y equals 23. Now, let's say there are n number of fights, right? In how many ways can you select 2 children from 24? You select 24 C2 ways and then you will subtract. So it will be 24 C2 minus x C2 plus x plus 1 C2 plus y C2. Because that event cannot occur per se. That is something which is not to be considered. That they cannot fight per se, the children of the same origin pairs, right? So 24C2 will be 24 into 23 by 2, right? 24 because 22 factorial and 24 into 23 by 2 factorial, which will be 2 only, minus xc2 plus x plus 1c2 plus yc2. So that we can simplify to x into x minus 1 plus x plus 1 into x plus x plus 1 into x whole by 2 and plus the yc2 part, which is yc2 can be actually written as y into so yc2 will be y factorial by y minus 1 whole factorial into 2 y minus 2 factorial, and that we can write as y into y minus 1 whole by 2, right? So we will write as y into y minus 1 by 2. At the end of this, what we can get is 24 into 23 by 2. If we subtract 12 and 23, then we will get 276 minus, over here we'll be getting x square plus y into y minus 1 by 2. So x square plus y into y minus 1 by 2. And then we can simplify. Okay. So now we have 276 minus x square plus y into y minus 1 by 2. Following here, we can place the value of 2x plus y equals 23. So y will be replaced with 23 minus 2x, right? So then we can write it as 276 minus x square plus 23 minus 2x into 22 minus 2x by 2. Now 22 minus 2x by 2 you can straight away write as 11 minus x, right? And over here you can write 276 minus of x square, and now we'll be expanding this. So 23 into 11 will be 253 minus 23x minus 22x will give us 45x minus 45x plus 2x square, right? So we'll get 276 minus of 3x square minus 45x plus 253. And then we can take out the bracket and then write as minus 3x square plus 45x 276 minus 253, which will give us a value of 23. Now, this is the number of fights that can occur in the family, and we can see clearly that it is dependent on the value of x. But we want to know the maximum number of fights which can occur, right? So what we have over here is a quadratic expression, right? Where 3x square plus 45 minus 3x square plus 45x plus 23. And we know one important thing, that when it comes to maxima or minima in integral and differential calculus, if you look at the other videos or any other study of mathematics, when we have to consider the fact that we have to find the maximum or minimum value of a certain equation or function, then we will know that d of fx by dx will be equal to 0. And then that part will be another issue where we have to find whether it is more than 0 or less than 0, the d2x by d2y square, d2x by dy square. That will be a different part where we'll have to figure out the actual maximum or minimum. But in most questions like these, it can come out directly what we want to find. So we want the maximum value of this function, right? Then let us say the derivative. If you know the derivative, 2 will come down. So you will get minus 6x plus 45. The 23 obviously, since the constant, will go. And this will be equal to 0. From here we will be getting that 45 equals to 6x. And x equals therefore 45 by 6 or 15 by 2 is 7.5. Now the x has a maximum value of 7.5, which means we cannot take 8 because then we'll be exceeding the maximum value. So, and since this is children we're talking about, they can only be in positive numbers, right? So therefore we'll take the value of 7. X equals 7 will be the number of times we need the maximum fights to take place, and that will be given by minus 3 into 49 plus 45 into 7 plus 23. At the end, we'll get the maximum number of fights as 191 fights. So these were a very cherry-picked assortment of questions from different topics ranging from probability to quadratic equations which we got. So at the end of it, we'll just like to say that please keep preparing, and these questions will be very helpful for our study and pedagogy which we'll be completing over here. And thank you very much for watching. Aspiring for more content and more viewers, of course, but it's all for the future of the nation, right?